Hi all, welcome to new class. Today's class is the continuation of the solution of system of homogeneous equations. So let us go through the problems. First one is solve the equations 4x plus 2y plus z plus 3w equal to 0, 6x plus 3y plus 4z plus 7w equal to 0, 2x plus y plus w equal to 0. So our first step is write the coefficient matrix. So A is equal to 4, 2, 1, 3, 6, 3, 4, 7, 2, then 1. Here no coefficient of Z, so 0, then 1. So this is coefficient matrix A. Now here we have to find the rank of this coefficient matrix. That is, we have to find the number of non-zero rows here. So for that, let us do the operations. That is, let us make these elements 0. That is, let R2 implies 2R2 minus 3R1, and also R3 implies 2 times R3 minus R1. Then here we will get, so first row is same, that is 4, 2, 1, 3. Then here we will get 0. Then 2R2, that is 6 minus 6, that is 0. Then 8 minus 3, that is 5. Then 14 minus 9, that is 5. Then here 0. Then 2 minus 2, 0. Then 0 minus 1. Then 1 into 2, 2 minus 3, that is minus 1. Now let us make these elements 0. That is, let us do the operation. R3 implies 5 times R3 plus R2. So here we will get 4, 2, 1, 3, 0, 0, 5, 5. Then here 0, 0. Then here we will get 0, 0. So here this is the reduced form of this matrix. So here number of non-zero rows are 2. So the rank of A is equal to 2 here, and the number of unknowns n is equal to 4, that is x, y, z, w. So here rank of A is less than n. So the system has infinite number of solution, that is non-trivial solution. So here infinite number of solutions. So here we have to assume value for n minus r numbers. That is, here we have to find n minus r. So here n minus r equal to 4 minus 2. So that is equal to 2. So we have to assume value for, so assume value for 2 variables. So we have to assume value for n minus r variables here. So let, and from this we can write Ax equal to 0. So this one we can write as 4x plus 2y plus z plus 3w equal to 0, and 5z plus 5w equal to 0. Now we can assume values for 2 variables. So let us assume w equal to k1. And while assuming w equal to k1, we can find the value of z from this equation. Now let us assume value for any of x or y. So let y is equal to k2. Then from this equation we will get 5z is equal to minus 5w and z is equal to minus w, that is minus k1. So z is equal to minus k1. So from this equation we can write 4x is equal to minus 2y minus z minus 3w, that is minus 2 into k2, then minus of minus plus k1, then minus 3 into w, that is 3k1. So here we will get minus 2k2 minus 2k1. So x is equal to k1 plus k2, that is minus of k1 plus k2 divided by 2. So x is equal to minus of k1 plus k2 divided by 2 and y equal to k2, then z equal to minus k1 and w is equal to k1. So this is the solution of this system of equations. Next question is, solve the equations x1 plus 3x2 plus 2x3 equal to 0, 2x1 minus x2 plus 3x3 equal to 0, 3x1 minus 5x2 plus 4x3 equal to 0, x1 plus 17x2 plus 4x3 equal to 0. So our first step is write the coefficient matrix A, that is 1, 3, 2, 2 minus 1, 3, 3 minus 5, 4, 1, 17, 4. So this is the coefficient matrix. Now we have to find the rank of this matrix. So for that, let us make these elements 0. That is, let us do the operations. R2 implies R2 minus 2 times R1. Then R3 implies R3 minus 3 times R1. R4 implies R4 minus R1. So here we will get 1, 3, 2, then 0, then minus 1, minus 6, that is minus 7, then 3, minus 4, that is minus 1, then here 0, then minus 5, minus 9, that is minus 14, then 4, minus 6, that is minus 2, then 0, then 17 minus 3, that is 14, 4 minus 2, 2. Now here we can make this element 0, that is R4 implies R4 plus R3, that is 1, 3, 2, 0 minus 7 minus 1, 0 minus 14 minus 2, 0, 0, 0. Here also we can make this element 0, that is R3 implies R3 plus 2 times R2, that is 1, 3, 2, then 0, minus 7, minus 1. So here we will get 0. So this one 0. This one also we will get 0. Then 0, 0, 0. Now here the rank of this matrix A is equal to, rank of A is equal to the number of non-zero rows, that is 2. And the number of unknowns are x1, x2, x3, that is 3. So here rank of A is less than the number of unknowns, that is non-trivial solution. That is, here we have to assume value for n minus r variables. So here n minus r is equal to 3 minus 2, that is 1. So here we have to assume value for one variable. So from this last reduced form, we have to write ax equal to 0. That is x1 minus 3x2 plus 2x3 is equal to 0. Then minus 7x2, then minus x3 equal to 0. Now let us assume value for x3. So x3 is equal to k1. So from this equation we can write x2 is equal to or minus 7 x2 is equal to x3. So x2 is equal to x3 divided by minus 7, that is minus k1 divided by 7. Then from the first equation we can write x1 is equal to minus 3 x2 minus 2 x3. Now put the values of x2 and x3 here. So minus 3 into x2 is minus k1 by 7, then minus 2 into k1, that is equal to, so here we will get 3 minus 14, that is minus 11 by 7 k1. So the solutions are x1 is equal to minus 11 by 7 k1, x2 equal to minus k1 by 7, and x3 is equal to k1. And here we can assume any variable for the value k1. That is, here we can assume x2 is equal to k1 also, or x3 equal to k1. So this is the solution of this system of equations. Next question is, find the values of lambda for which the equations 3x plus 4y minus lambda z equal to 0, 4x minus 2y minus 3z equal to 0, 2 lambda x plus 4y plus lambda z equal to 0 have a non-trivial solution. Obtain the most general solutions in each case. So here we have to find the value of lambda, and it is given that it have a non-trivial solution. So for a non-trivial solution, we have determinant of A is equal to 0. That is, determinant of the coefficient matrix is equal to 0. So for that, let us write matrix A. Matrix A is 3, 1 minus lambda, 4 minus 2 minus 3, then 2 lambda, 4, then lambda. So this is matrix A. Then we have to find the determinant of A, that is determinant of A is equal to determinant of 3, 1 minus lambda, then 4 minus 2 minus 3, 2 lambda, 4, then lambda. So determinant of A is equal to 0. So here we will get 3 into minus 2 lambda, then plus 12, minus 1 into 4 lambda, 4 lambda, then plus 6 lambda, then minus lambda into 16 plus 4 lambda equal to 0. So here minus 6 lambda plus 36, then here 10, that is minus 10 lambda, then minus 16 lambda minus 4 lambda square equal to 0, that is minus 4 lambda square minus 6, 16, 32, that is minus 32 lambda plus 36 equal to 0, dividing by minus 4, that is lambda square, then plus 8 lambda minus 9 equal to 0. So here we have to find the solution of this equation. So by using the calculator we can find the solution. So we will get lambda is equal to 1 and minus 9. So this is the value for lambda. So lambda is equal to 1 and minus 9. Now we have to find the solutions of these equations in each case. So here we get lambda equal to 1 and minus 9. So when lambda is equal to 1, then what will be the coefficient matrix A? So A is equal to 3, 1, minus 1, 4, minus 2, minus 3, 2, 4, 1. So this is the matrix A. Now we have to find the solutions of this matrix. That is, here we have to find the rank of this matrix A. So for that, let us make these elements 0. That is, R2 implies R2 minus 4 by 3, R1, and also R3 implies R3 minus 2 by 3 R1. So here we will get 3, 1 minus 1, 0, then minus 2 minus 4 by 3. Minus 2 minus 4 by 3, that is minus 10 by 3. Then here minus 3 plus 4 by 3, that is minus 5 by 3. Then here 0, then 4 minus 2 by 3, that is 10 by 3. Then 1 minus of minus plus 2 by 3, that is 5 by 3. Now we can make this element is 0, that is R3 implies R3 plus R2, that is 3, 1 minus 1, 0, minus 10 by 3, minus 5 by 3, 0, 0, 0. So here we got one row as 0, that is rank of A is equal to 2 here, and here number of unknowns are x, y, z, that is 3. So rank of A is less than the number of unknowns. So here non-trivial solution. Now here we have to assume value for n minus r variables. So here we have to assume values for n minus r variables. So n is 3 minus 2, that is n minus r equal to 1 variable we have to assume. So from the reduced matrix we can write 3x plus y minus z equal to 0, then minus 10 by 3y minus 5 by 3 z equal to 0. So assume value for one variable, that is let z equal to k. That is from this equation we can write minus 10 by 3y is equal to 5 by 3z, or we can write minus 10y is equal to 5 k1, that is y is equal to minus k1 divided by 2. Now from the first equation we can write 3x equal to minus y plus z, that is equal to minus k1 divided by 2, then plus k1, that is equal to 3 by 2 k1. So this is 3x. So we get x is equal to k1 divided by 2. So the solutions are x is equal to k1 by 2, then y is equal to minus k1 by 2, and z is equal to k1. So this is the solutions for lambda is equal to 1. Now we have to find the solutions for lambda is equal to minus 9. Now let us put the value of lambda equal to minus 9. So the coefficient matrix A is equal to 3, 1, 9, then 4, minus 2, minus 3, minus 18, 4, minus 9. Now we have to find the rank of this matrix. So for that we have to make these elements 0. That is R2 implies R2 minus 4 by 3 R1, and R3 implies R3 plus 18 by 3, that is 6 R1. So here we will get 3, 1, 9, then 0, then minus 2 minus 4 by 3, that is minus 10 by 3, then minus 3 minus 4 by 3 into 9, that is minus 15. Then next is, this is 0, then 4 plus 6, that is 10, then minus 9 plus 54, that is 45. Now here we can make this element 0, that is R3 implies R3 plus 3 times R2. So here we will get 319, 0 minus 10 by 3 minus 15, then 0. So this one will be 0 here, that is 10 minus 10. So 0, then 45 minus 45. So this one also 0 here. So this is the reduced matrix. So here rank of A is equal to the number of non-zero rows are 2 and number of unknowns equal to x, y, z, that is 3. So rank of A is less than the number of unknowns. So non-trivial solution. So here to find the solution we have to find, or let us assume value of n minus r variables. So here n minus r is 3 minus 2, that is we have to assume value for one variable. So from this last reduced matrix we can write 3x plus y plus 9z equal to 0, then minus 10 by 3y minus 15z equal to 0. So let us assume z equal to k1 or k. Then we will get y. So y is equal to 15z divided by minus 10 by 3, and that is equal to 15k divided by minus 10 into 3. So here we will get 3 into, that is equal to minus 9 by 2k. Then from the first equation we can write 3x equal to minus 5 minus 9z, that is minus y is 9 by 2k, then minus 9k, that is equal to minus 9 by 2k, and that is 3x. So from this we get x is equal to minus 3 by 2k. So x is equal to minus 3 by 2k and y equal to minus 9 by 2k and z equal to k are the solutions for lambda equal to minus 9 in this case. So that is about the solutions of homogeneous equations. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.